The undersized ground wire, sometimes called a static or bootleg ground, was an accepted grounding practice in older electrical installations. This was common in the early to mid-20th century, before the National Electrical Code, or NEC, began requiring a full-size ground wire in 1962. Before 1962, the NEC didn't explicitly prohibit the use of undersized ground wires. However, it recommended that a full-size ground wire be used, and it didn't consider undersized ground wires to be a reliable or effective grounding path. To properly ground metal boxes and other electrical equipment in an older installation with undersized ground wires, there are steps that can be taken. Firstly, install grounding rods. Drive copper-clad or galvanized steel grounding rods into the ground near the electrical panel. The grounding rod should be at least 8 feet long and spaced a minimum of 6 feet apart. Secondly, run grounding wires. Connect an 8 AWG or larger copper wire from the grounding rods to the electrical panel. Thirdly, bond metal boxes. Connect a 12 AWG or larger copper wire from the grounding rods to the metal boxes in the garage and screen porch. You should not rely on the undersized ground wire in the Romex as a sufficient grounding path for metal boxes. Verify that the circuits feeding the metal boxes are not overloaded. Have the electrical system inspected by a qualified electrician to ensure that it meets current safety standards. Consider upgrading the electrical system to include proper grounding throughout the house. This may involve running new wire and installing new outlets and switches. Addressing the situation involves several key considerations. Firstly, understanding the historical context of electrical wiring practices is crucial. Prior to the widespread adoption of standardized grounding methods, undersized ground wires were sometimes used, often referred to as static grounds. While these were not as effective as modern grounding systems, it's important to understand their presence and limitations. Secondly, when encountering metal boxes in older installations with these undersized grounds, several methods can be employed to improve safety. One option is to install supplemental grounding electrodes, such as ground rods, and connect them to the metal boxes using appropriately sized grounding conductors, typically 12 AWG or larger copper wire. This provides a more robust path for fault current to return to the source, enhancing safety. Thirdly, another approach is to consider retrofitting the electrical system to include proper grounding throughout the house. This involves replacing the existing wiring with modern Romex cable that includes a full-size grounding conductor. While this can be a more extensive project, it offers the most comprehensive solution for improving electrical safety. Fourthly, when working with metal boxes, it's essential to ensure that all connections are properly made and that the boxes are securely mounted. This includes using appropriate grounding screws or clips to connect the grounding conductors to the metal boxes. Additionally, any splices or terminations should be made within the boxes and properly secured using wire connectors or other approved methods. Fifthly, it's crucial to verify that the circuits feeding the metal boxes are not overloaded. Overloaded circuits can create excessive heat, which can damage wiring and increase the risk of electrical fires. To prevent overloading, consider redistributing the load across multiple circuits or upgrading the circuit breaker panel to provide additional capacity. Sixthly, consulting with a qualified electrician is highly recommended when dealing with older electrical systems. An electrician can assess the condition of the wiring, identify any potential hazards, and recommend appropriate solutions. They can also ensure that any electrical work is performed in accordance with local codes and regulations. Seventhly, another important consideration is the presence of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect ground faults and quickly shut off power to prevent electrical shock. Installing GFCIs in areas where there is a risk of water exposure, such as bathrooms and kitchens, can significantly improve electrical safety. Eighthly, when evaluating the condition of the electrical system, it's important to inspect the wiring for any signs of damage or deterioration. This includes looking for cracked or brittle insulation, loose connections, and signs of corrosion. Damaged wiring should be repaired or replaced immediately to prevent electrical hazards. Ninthly, in addition to grounding and GFCIs, surge protection devices can also help protect electronic equipment from damage caused by power surges. Surge protectors can be installed at the main electrical panel or at individual outlets to provide protection against voltage spikes. Tenthly, it is prudent to have the electrical system inspected by a qualified electrician to ensure that it meets current safety standards. Lastly, when dealing with electrical systems, safety should always be the top priority. Always disconnect power to the circuit before working on any electrical components, and follow all applicable safety precautions. By taking these steps, you can ensure that your electrical system is safe and reliable. When addressing an older electrical system with undersized grounding conductors and metal boxes, several factors must be carefully considered to ensure safety and compliance with current electrical codes. Firstly, understanding the history and evolution of electrical codes is essential. In the mid-20th century, particularly before the 1960s, electrical wiring practices were less standardized, and the use of undersized grounding conductors, often referred to as static grounds, was relatively common. These older systems typically did not provide the same level of protection against electrical faults as modern systems with full-size grounding conductors. Secondly, when encountering metal boxes in an older installation with undersized grounding conductors, it's crucial to recognize the potential hazards associated with this configuration. Metal boxes can become energized if a fault occurs within the wiring, posing a risk of electric shock to anyone who comes into contact with the box. Therefore, proper grounding of the metal boxes is essential to provide a safe path for fault current to return to the source, tripping the circuit breaker or fuse and de-energizing the circuit. Thirdly, several methods can be employed to improve the grounding of metal boxes in older electrical systems. One common approach is to install supplemental grounding electrodes such as ground rods and connect them to the metal boxes using appropriately sized grounding conductors. The size of the grounding conductor is typically determined by the size of the circuit supplying the metal box in accordance with the National Electrical Code, or NEC. For example, a 12 AWG copper grounding conductor is often used for 15 amps and 20 amp circuits. Fourthly, another method for improving grounding is to install a separate grounding conductor that runs directly from the metal box back to the main electrical panel. This is known as a home run grounding conductor, and it provides a dedicated path for fault current to return to the source. Home run grounding conductors are particularly useful in situations where the existing grounding system is inadequate or unreliable. Fifthly, when installing grounding conductors, it's important to ensure that all connections are properly made and that the conductors are securely attached to the metal boxes. This typically involves using grounding screws or clips that are specifically designed for this purpose. It's also important to ensure that the grounding conductors are protected from physical damage and corrosion. Sixthly, in addition to improving the grounding of metal boxes, it's also important to ensure that the overall electrical system is in good condition. This includes inspecting the wiring for any signs of damage or deterioration, such as cracked or brittle insulation, loose connections, or corrosion. Any damaged wiring should be repaired or replaced by a qualified electrician to prevent electrical hazards. Seventhly, another important consideration is the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect ground faults and quickly shut off power to prevent electrical shock. GFCIs are particularly useful in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Installing GFCIs in these areas can significantly improve electrical safety. Eighthly, when working on electrical systems, it's important to follow all applicable safety precautions to prevent electrical shock and other hazards. This includes disconnecting power to the circuit before working on any electrical components, using insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. Ninthly, consulting with a qualified electrician is highly recommended when dealing with older electrical systems. An electrician can assess the condition of the wiring, identify any potential hazards, and recommend appropriate solutions. They can also ensure that any electrical work is performed in accordance with local codes and regulations. Tenthly, it is prudent to consider retrofitting the electrical system to bring it up to current safety standards. This may involve replacing the existing wiring with modern Romex cable that includes a full-size grounding conductor, as well as installing new outlets, switches, and circuit breakers. While retrofitting can be a significant investment, it can provide a substantial improvement in electrical safety and reliability. Lastly, when making modifications to an existing electrical system, it's important to obtain the necessary permits and inspections from the local building department. This will help ensure that the work is performed in accordance with applicable codes and regulations, and that the electrical system is safe and reliable. In summary, addressing the challenges of undersized grounding conductors and metal boxes in older electrical systems requires a thorough understanding of electrical codes, best practices, and safety precautions. By following these guidelines and consulting with a qualified electrician, it's possible to improve the safety and reliability of older electrical systems and protect against electrical hazards. Several factors must be considered when addressing the situation of undersized ground wires and grounding metal boxes in an older electrical system. Firstly, it's essential to understand the historical context of electrical wiring practices. Older homes often have wiring systems that predate current safety standards, including the use of undersized ground wires. These wires were sometimes referred to as static grounds and were not intended to provide the same level of protection as modern grounding systems. Secondly, metal boxes in electrical systems need to be properly grounded to prevent electrical shock hazards. When a fault occurs in a circuit, such as a short circuit, the metal box can become energized, posing a risk to anyone who touches it. Grounding the metal box provides a path for the fault current to flow back to the source, tripping the circuit breaker or fuse and de-energizing the circuit. Thirdly, when dealing with an older electrical system that has undersized ground wires, it's important to assess the overall condition of the wiring and determine the best course of action. In some cases, it may be possible to supplement the existing ground wire with a separate grounding conductor connected to a grounding electrode system such as a ground rod. This can improve the grounding of the metal boxes and provide a safer electrical system. Fourthly, if the existing wiring is in poor condition or if the undersized ground wires are not providing adequate protection, it may be necessary to rewire the entire circuit or even the entire house. This is a more extensive and costly option, but it can provide the greatest level of safety and reliability. Fifthly, when grounding metal boxes in an older electrical system, it's important to use proper grounding techniques and materials. This includes using grounding screws or clips to connect the grounding conductor to the metal box and ensuring that all connections are tight and secure. It's also important to use the correct size of grounding conductor for the circuit, as specified by the National Electrical Code, or NEC. Sixthly, ground fault circuit interrupters, or GFCIs, are an important safety device that can help protect against electrical shock. GFCIs are designed to detect ground faults and quickly shut off power to the circuit, preventing injury or death. GFCIs should be installed in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Seventhly, when working on electrical systems, it's important to follow all safety precautions and to disconnect power to the circuit before starting any work. This includes using insulated tools, wearing appropriate personal protective equipment, and following all applicable electrical codes and regulations. Eighthly, consulting with a qualified electrician is always a good idea when dealing with older electrical systems. An electrician can assess the condition of the wiring, identify any potential hazards, and recommend appropriate solutions. They can also ensure that any electrical work is performed safely and in compliance with all applicable codes and regulations. Ninthly, it's important to note that electrical codes and regulations vary depending on the location. It's essential to check with the local building department to determine the specific requirements for electrical work in the area. Tenthly, when making any changes to an electrical system, it's important to obtain the necessary permits and inspections from the local building department. This helps ensure that the work is performed safely and in compliance with all applicable codes and regulations. Lastly, it is prudent to consider the long-term costs and benefits of different options for addressing undersized ground wires and grounding metal boxes in an older electrical system. While rewiring the entire house may be the most expensive option upfront, it can provide the greatest level of safety and reliability in the long run. Supplementing the existing ground wire with a separate grounding conductor may be a more cost-effective option in the short term, but it may not provide the same level of protection. In summary, addressing the issue of undersized ground wires and grounding metal boxes in an older electrical system requires a careful assessment of the wiring, a thorough understanding of electrical codes and regulations, and a commitment to safety. By following these guidelines and consulting with a qualified electrician, it's possible to improve the safety and reliability of older electrical systems and protect against electrical shock hazards.